Hello students, how are you? Today we are going to start our one short lecture first of physics, electrical potential and capacitance. So today we are diving into electrical potential and capacitance. Let's start with example. If I left a ball, I give it gravitational potential energy in bracket PEG is the formula of gravitational potential energy. Okay, the gravitational potential is a property of location itself. It's the potential energy per unit mass. So now next topic, definition of electric potential. In electrostatic we do the same thing. We define electric potential volt as the electric potential per unit charge. So it's a property of the electric field independent of the test charge, and it tells you the energy stored in a location if you place a charge them. Now we will discuss the formula for electrical potential. So the formula is electrical potential energy by charge, and this is important. Okay, now we will study about their units. So their units are joules per coulomb. Which we call as volt. A large potential means a location has the capacity to do a lot of work on a charge. So now our next topic is the potential field. In that we are going to learn potential due to point charge volt, potential difference voltage, work energy theorem and relationship to electric field. So now we will start with potential due to point charge. So the formula for this is volt to K charge on. Okay, you have to remember every formula in this lesson. And for this, V is a scalar quantity. This is a huge advantage if you have multiply charges, you just add their potential algebraically. No tricky vectors, maths. Okay? Now we will start with next topic in the potential field. Potential difference in voltage. It's also known as delta V. The sign for this is delta V. This is the charge in potential energy per unit charge between 2 points A and B. So the formula for potential difference is delta V is equal to VB minus VA. Okay, this is formula. And you have to also remember every formula because the formula is used in MCQs also and in numericals also. So they tell you what are the potential difference. So whenever they say you find potential difference, you need this formula. Okay, so remember it. So our next topic is work energy theorem. The work done by an external force to move a charge between 2 points is called work energy theorem. For solving the MCQs for work energy theorem, the formula is used: work T is equal to charge delta work. It's really important, so much important, because you can see in last previous 5-year paper there are one question on work energy theorem. So we will try on this. We will try MCQs and also try some questions and answers for this. Okay? So our next topic is relationship to electric field. Electric potential and electric field are fundamentally linked. How? Like the electric field always point in the direction of the steepest decrease in electric potential. Okay? And the formula for this is this formula is also important. Okay? Every formula you have to make a formula book for that, so you can remember where you have to put that formula in which numerical or which theorem. Okay? Now think of it like a topographical map. Electric field lines are perpendicular to equipotential surface. The surface where V is constant. V means volt. No work is done moving a charge along a equipotential surface. No work is done moving a charge along an equipotential surface. Okay, you have to remember this also. In NEET there was asked in which theory equipotential surface is not work done. So the option was in relationship to electric field. Okay.
So our next topic is capacitance and capacitors. A capacitor is a device designed to store electric charge and electric potential energy. It typically consists of two conducting plates separated by an insulator, and the insulator is a dielectric. You have to remember this. When the insulator is connected to the battery, a source of voltage delta V and charge is separated, creating an electric field between the plates. Okay, now we will discuss definition of capacitance. It is the measure of capacitor ability to store charge. Okay, it is defined by the ratio of charge stored to the potential difference across its plane. Okay, so the formula for capacitance is capacitance charge volt, and unit is coulomb per volt This is also defined as farad. F. Farad is one of the huge we often use in microfarads or picofarads. Okay, it is used for huge charge. Okay, so our next topic is parallel plate capacitor. The most common capacitor is the parallel plate capacitor. Its capacitance depends purely on its geometry. For this formula is capacitance and D.
So this is the permittive of free space. A is the area of the plate, like larger area is equal to higher capacitor. And D is the separation between the plates. Smaller distance is equal to higher capacitance. These show that capacitor is an intrinsic properties determined by it is determined by how it's built, not by the voltage applied or the charge it holds. So in this chapter the last topic is energy stored in a capacitor. Because capacitors store charge separation, they store energy also. The total energy stored is equal to the work done in charging it. Okay, for formula, total energy half of Cv square is equal to half of Qv is equal to Q2 2C. And capacitors are essential for power delivery like camera flashes and timing circuits. Okay, so this was the last topic of this lesson. Hope you all understand everything. If you have any doubt, you can DM me on Instagram. Thank you. Please subscribe, like, and share the video to your friends also, so they also get some valuable contents. Okay, and now I will tell you this formula is important. Every formula is important in this formula. This formula. This formula is very important. You have to note this. This formula also. Every formula. Whenever I am writing everything, you also write so you can get all. Okay. This is also important. So these were important topics for NEET, JEE and other entrance lecture. This is one short video, so I have done smaller. Hope you all like my lectures also. Thank you.